In this video, we're going to talk about the solution to the tangent line problem. Let's just go back over the tangent line problem really quickly. Remember, we had a function and it's continuous at A, and so we'll have a point on the graph corresponding to A, and we want to find the slope of the tangent line at that point. Okay. So as I mentioned in the previous video, one of the difficulties is finding the slope of that line because we only have one single point on there. If we have 2 points on a line, then it's pretty straightforward to find the slope of the line through those 2 points. And we can use the slope formula from algebra class. So if x1, y1 and x2, y2 are points on a line, and x1 is not equal to x2, so in other words they have different x coordinates, then the slope of the line is y2 minus y1 over x2 minus x1. And again, these x coordinates have to be different, right? Because otherwise we would divide by 0 here. So we're going to use this to get the solution to the tangent line problem. And so here's the setup for how we're going to do this. All right, so here's our picture of our graph, and there's the point A comma f of A at which we want to find the slope of the tangent line. What we're going to do is move some distance to the right or to the left. In this picture, we just move to the right some distance, and whatever that distance is, we're going to call h. So maybe we move 2 units to the right, and in that case h would be 2. So, or 2 units to the left, in that case h would be negative 2. Okay, and so we will get a point over when we move to the right or to the left. That point will be a plus whatever that number h is. So for instance, if we move 2 units to the right, that would be a plus 2. And then on the graph, we would go to the graph of the function, and there's a point on the graph corresponding to that, if it's a nice enough function, right? And so then we will have 2 points, and we can think about the line that goes through those 2 points there, just like that. Okay, so this coordinates of this point would be a plus h, right, the x coordinates, and then f of a plus h, that's whatever we get when we plug in a plus h into the function. So whatever the output is, that will be the coordinates of those 2 points. And so we'll have 2 different points on the line, and so we can calculate the slope of the line joining those 2 points with the slope formula from college algebra. So it'll be y2 minus y1 over x2 minus x1. So we get this formula here, and we can simplify that slightly. In the bottom we have 2 like terms a and minus a, so the simplified formula for finding the slope is f of a plus h minus f of a all over h. Okay, so that will give us 2 points, and with 2 points we can easily calculate the slope, right? But you're probably thinking, okay, fine, I see you have 2 points and you can use the slope formula to calculate it, but how does this line give us the slope of the tangent line, right? It's not the tangent line, it's totally different from the tangent line. And so the key to that is to think about making h not big like we have it here, but smaller and smaller. And so that's what we're going to do next, right? In the next picture, I'm going to make h a little bit smaller, right? And you can see here the line is maybe a little bit closer to what the tangent line would look like. And then I'm going to make h a little bit smaller, and again, I could repeat the same process and calculate the slope. And then I am going to move h a little bit closer, right? And so now h is getting smaller. This line now is a lot closer to the tangent line than what we had before. And we could make h a little bit smaller. And so now those points are getting really close together to each other. And that line, even though it goes through 2 different points, is pretty close right to the tangent line. So what we're doing is making h get smaller and smaller, in other words, closer and closer to 0. Okay, and then we would look at that slope formula. So as h gets closer and closer to 0, the slope of that line would be closer and closer to the slope of the tangent line. So hopefully that kind of language sounds familiar to you, right? What we would do is take the limit as h goes to 0 of that slope formula right there. And that turns out that that is the solution to the tangent line problem. So if f is a function continuous at a number a, and the slope of the tangent line is going to be given by this formula here, the limit as h goes to 0 of f of a plus h minus f of a all over h, if that limit exists. Okay, so this will give us the slope of the tangent line, and it is the solution to the tangent line problem. We haven't really talked about why, in general, you would want to solve the tangent line problem. We will do that later on in later units, talk about exactly why people were interested in solving this problem. So in the next video, what we're going to do is introduce another name for this limit here. It's called the derivative at a point. And then we're going to do some small example of how to calculate this limit.